Thank you, Engineer Muqtaj Ali, for the presentation. Ladies and gentlemen, now it is my pleasure to introduce our second speaker. Engineer Dr. K.S. Kannan was a professor at the Faculty of Mechanical Engineering, University Technology Malaysia, UTM. He is currently a local energy consultant and has more than 30 years experience in energy research and consultancy. His expertise is in energy efficiency practice and technologies in buildings and industry. Without further ado, please welcome Engineer Dr. K.S. Kannan.
Good morning, Engineer Dr. Zuhairi and my fellow speakers and ladies and gentlemen. I thank Engineer Zuhairi for giving me this opportunity to present something on the energy efficiency and management of buildings. You notice that the thing has been titled as approach. So I've used, of course, the standards which have been developed as the approach. First, the standards is actually the code of practice which has to go towards that. And the other thing is that although I have worked with buildings for a very long time, I have now switched to industry. This was because my previous appointment in PTM was on industry, and then even now I'm working with UNIDO, also related to industry. So I'll quickly run through this because I tried to catch up some time. So of course for the building sector, EE is the code of practice. This is the 2007 version of 1525. We are now revising it to, and it will be coming out in the next year, the 2013. It originally was out in 2001. Now, what I want to do here is I just want to show this application in the building sector. And the first application of this was in the new building, which is the building of the Ministry of Energy, Green Technology and Water. So these are the areas which are covered by the standards. And basically we see that we have passive design elements and also active elements. Now we had a bit of focus on the passive because there is a lot of gain which can be done on these passive design elements. And once it is architecturally built correctly, then you find that there is less work for us to do. So first thing is of course the building orientation. You can see that buildings have to be, I don't know why it's running, oriented so that we have most of the windows and glazing spacing north-south. And typically this was what was used in the new building. Now then we have this what we call the OTTV, which is quite well deliberated in the codes. And in the OTTV, the base building OTTV is 51 meters squared. In the 2001, it was put as 45, but in the 2007, it is revised to 50. But you can see that the building, the new building, has a OTTV of around 35, and so subsequent buildings also have a OTTV of around that. So standards are always not sort of rigid as such. Standards only give the minimum which should be complied. That means they just eliminate bad practice, but there are always practices which are better. Then we have this encouraging of daylighting. I think this is very much again stressed in the standards. Daylighting is a very important technology, and so we can design so that we can use daylighting in most of the buildings. So you can see that certain areas where near the facade more amenable to daylighting, but here then you have some in the corridors and so on. So we have to maximize daylighting as far as possible. Lighting, as far as lighting is concerned, in order to take advantage of daylighting, we have this so-called photocells, so that if there's enough daylight, then we can switch off the artificial lighting, and we can also base the lighting on the occupancy. Now the lighting design, again the illumination is, we use 350 lux, 300 to 400 lux. Although at that time when we were using the illumination society of I think Europe, many architects were using up to 600 to 700, but we felt that was a bit too much. 300 to 400 lux is just enough for general office work. Of course, if you want to do particular things like proofreading or any other detailed thing, then you sort of use your own separate task lighting. Now the air conditioning system, here the air conditioning system, we don't have a chiller system because the chill water is applied by the district cooling system. But we use these variable speed drives, also energy efficient motors and so on, so as to increase the efficiency. And at the same time, we have this carbon dioxide sensors to sort of control the amount. But because the building is very sparsely occupied, we never actually reach the level of the CO2. And we also have the heat recovery wheel, which helps to reduce the cooling load of the fresh air intake. Temperature control set point, of course, 24, which is now being encouraged by the government. Proposed by the MS 15-2007 is also 23 to 26, but in the next future revision, we are having it from 24 to 27. We notice that we can use a higher indoor temperature, comfortable temperature, provided we have a good or acceptable air motion. Now, we found that this friction losses is a very significant thing for air conditioning, especially the friction losses in the ducts. This can be overcome by having larger ducts and also reduce the friction. So therefore, you find that if we can have a better ducting system, then we can reduce the size of the chill water pumps, fan capacity, and also thereby reduce energy consumption. Electronic air cleaners is also one feature where you can use it to remove the pollution from the the outdoor air, and at the same time also this requires much less maintenance and easier to remove the dust. Energy efficient office equipment, again, if you use the latest technology equipment, then we can reduce the energy of the taken up by the office equipment, such as computer, monitor, printer, copier, and fax. Now, the other good feature is using of sub-metering purposes, and in that, I think if you have different outlets for plug loads and other loads and so on, then we can easily monitor or even measure the loads separately to the various end users, such as air conditioning, lighting, plug loads, and also other loads. And this has been well done in that building. A good energy management system is always important, and in the standards it's recommended energy management system for buildings which are of 4,000 square meters and above. So therefore, we find that this is a very useful tool, especially for knowing how much energy you're using, where you're using, and also to control the amount of energy. And we have not, of course, removed the renewable energy. That's why this code includes renewable energy. So here we have a PV panel on the rooftop, which is used to power the water wall in the atrium. We also have a rain water harvest system. Right? So therefore, these features are also there. So in the code, you find that the code actually is not that prescriptive. I mean, it's not given values for certain things, but also it's a good guideline. And that's why it's called the code of practice. Now then, you find that the buildings energy efficiency index have gone down. Normal buildings which were around 250 to 300 because of the newer building has come down to 100. 100 is somewhat a very good, very energy efficient building. The green energy office building is around that 75 or so. The zero building, which actually the GEO was supposed to be the ZEO, but then it could not achieve that. So if it has enough renewable energy, then you find that the building index can go much lower. And down to 34, so it is possible. Then you also have next the energy commission building, which has also got features such as shading features, sloping roof, rooftop garden, and so on. Light shelves, which help to again bring down the energy. And the green energy office has various sustainability features. I won't go to that in detail, but you can see that daylight is there, floor slab cooling. The only disadvantage of the floor slab cooling was that we ignored the air motion, so therefore there was a bit of stuffiness. Thermal storage system, the solar energy, and then the also using the roof as a cooling tower. Now then, the other one is the energy management. We finally have concluded that energy management is actually a very important tool, especially for both the building and the industries, and also transport and so on. If the energy is managed well, then you don't even have to go into new technologies as soon as you want. That means you can delay going into new technologies. So energy management, as I said, making energy efficiency part of your culture and operations. So the purpose is to, again, improve energy performance. And the scope of this new ISO 50001, it has now been adopted by Malaysian standards, so at least MS ISO 50001. So it goes on to measurement, documentation and reporting, operation and design and procurement practices. And so applicable to all organizations, not only buildings but also industries. And you see that the energy performance as such covers various other, not only energy efficiency, but also the energy intensity, energy use, energy consumption, and all other factors. So although the performance per se is not specified, but that is what is covered in the standards. It uses the same plan, do, check, act approach as the other ISO standards, but you find that it is secured by means of a good management system, and then is continual improvement to better the efficiency. So that is the thing. Now we have the main thing is the management responsibility, which is the commitment of the top management. This is the first step, and whether it's a building operated or whether it is an industry operated, will have the top management support the system, and if that is so, then you can continue with that. And once they commit, then of course they have a policy, they have enough resources, and then they have a good intention to, or some corporate social responsibility. So these are the things, commitment to continual improvement, make resources available, and also a framework or target. Now then is the planning stage, and planning stage involves a bit of technical. So this is where the plant and maintenance people are involved, and they have to know how much energy is being used, which are the uses, the biggest uses of energy, develop certain baseline and indicators, identify this system optimization opportunities. When we say system optimization, we don't look just at the equipment alone, but also the equipment and also the function it does. For example, the air conditioning system, not only the chiller, we also look at the chiller, the pumps, the motors, the cooling towers, the handling units, and all as a system. And again, you have some renewable energy options which can come into the picture. Now, once you have that, then of course is the implementation, and in the implementation, the most important part is the training and awareness. So training and awareness is very, very important for all levels of the management and also the low-level staff. Then the documentation, so that the documentation is always there. It does not leave the office or the industry. It does not live together with the person. It is always maintained in the office. Now again, the design, then of course you use the energy-efficient design based on the other standards, which is like MS 1525 or something else. And operation and maintenance also is again a key point here. So after they implement, then we have the point where you check. So you have the technical checking, monitoring and targeting, the equipment checking, some system checking to make sure that everybody does their part, and also that whether it conforms to the required standards or whether it does not conform and so on. And the most useful indicator is the energy performance indicators. So we need to develop these indicators. It need not be a fixed indicator. It is actually something which is unique to your industry or to your office. So you develop your own system, you develop your own indicator, and you monitor that, so that will show how well you're doing. And then of course the process of a review by the management to see how well you've done or how far the resources they have spent have been used and all that. So how are we getting on? Are we getting on well? Have we done what we have set to achieve and so on? And then the future plan. So when you have this management review, then of course the top management becomes more convinced, and so therefore more resources are added to the organization so that they can carry on the thing. One is management review, but in the other way we also have to sort of report maybe to some authority. That will be the next step, where we have regulations coming in. Then we have to report to the other authority that on regarding this. So this part here is again very relevant and very useful, so that people have to be aware of what is going on. That means the management, although they have actually given the go ahead, they have to ensure that it's going on well. And then we say that you're not finished. This is not a project. It's something which you have to start all over again. That's why they say it's a continuous cycle, and very, very important for people to ensure that they get the right thing. Now, what does this energy management system achieve? This energy management system also has come out in as a book. I think it is this one. Also MS ISO 50001, available at CERIM. And it is good to have the company certified as MS ISO 50001 compliance. We at this UNIDO are now trying to give a lot of training, a lot of capacity building for this, both for the user as well as for the consultants who are going to put this into practice. And ultimately, we are going to develop experts who can implement this energy management system. So there is a management focus. That means management is committed towards that. Then we have a systematic activity, and you do things in a particular way, in a structured way. More they say is a structured way. You measure, you have values, you have a target, and you carry on to that. And you identify and focus on biggest users. So this is where they say, where do we start first? Where do we start first in the energy efficiency game? So then you identify which are the components in your industry or even your building which uses the most energy, and then so on. And again, I will always emphasize that training is the most important. So in this element of energy management, training is very important. Training and also what they say is continuing education. That's why I think in most associations and most professional things, we have this CPD, continuing professional development. It can also apply to the lower level of staff. So it is very important that training is done at an overall level, and focus on key people at all levels. And then focus on data and numerical methods. So measurement is very important. If you are not able to measure, if you're not able to know exactly how much you are spending or using, then it's going to be very difficult to manage. So that is also a stress on that. So you find that there is also a good link between this and the MS 1525, where MS 1525 actually specifies that you have to have sub-metering, you have to, these are the levels and so on. So that is the guide, and then this one is just the methodology of doing it. What we are saying that is there must be some system for you to follow, and therefore the system to follow is this energy management system. So there is, in a way, got the integrated approach. People, department, budgets, all are involved. Continuity through changes of personnel. This is again the most important. Every time when we do the audit, we go to the building. They don't have any drawings or any plans, and the person who was doing it previously is not there. So therefore, all the knowledge has gone with him, and the new person who has taken over starts right from the scratch. So this has to be avoided. And in fact, it's very common in the Malaysian scenario where we go to any building to audit, nothing, no records, and you have to start from scratch. It's a lot of waste of laborious tasks to be done here. And at the end, it's continual improvement and all about reducing energy costs. Although we talk about energy efficiency and so on, but ultimately it's reducing energy costs. And if you can reduce the energy costs, you can also withstand the rise in the tariff and so on. So basically, we can summarize these 6 key concepts. First one is commitment. That is the key, the starting point. You must have that. And you identify roles and opportunities of everyone in the organization. Then the significant energy users, which are the energy end users which are significant. Then energy performance indicators. There's no fixed energy performance indicator. I said you can always develop your own indicator and then target it or manage it. Opportunities list. What are the savings I can get? What are the opportunities? What are the practices which I can use to reduce the energy consumption and also increase the efficiency? Operational control. How do I actually control this thing? You find that if the personnel is trained, then he has a commitment to sort of operate in a manner so as to reduce the energy consumption, because he knows that he has to care and he has his role to play in the energy management of the whole organization. But if he is not trained, then your energy management thing fails. And then the review is for the cycle to continue. The review, find out whether you have conformed or whether you have complied, or what are the things you have not complied, and so on. So this 6 key concepts is very vital in going through any energy efficiency proposal, especially for buildings and so on. Now, actually, it does not, because people think that whenever you have standards or ISO and all that, there is a lot of finance and also human resources which is necessary. But we say that it's not exactly that. If you look at the management resources, then of course, as I said, the opportunity is there. One is to actually make the commitment and go ahead. Policy, which is just a piece of paper, then to participate in a regular review meeting, make decisions as required, offer encouragement and support. So as far as the management is concerned, this is actually a very simple task to sort of for them to embark. Operational resources, this is where the plant people are involved. Completion of planning steps. Training, again, training is the largest cost. But now you have all this HTRF and all these schemes where you can get back the money when you put for training. Support from other departments, so everybody has to work together. Not only the production department, but also the accounts department and also the human resource department and so on. And then more time for energy manager to focus on energy efficiency. So the energy manager has to, of course, maintain the system, but he also has to do his part on improving the energy efficiency. Now, as far as the implementation cost is concerned for the energy management system, you need some consultancy support, but that can be overcome if you have sufficient training. And then, of course, the question of certification. Certification is optional. Certification is only if you want to show others that you have complied. But if you comply and you are happy with it, you find that there is an improvement in your bottom line or your energy performance indicators, then you carry on with it. But if you just want to go one step further, this actually certification is important for industries because later in future they say that you want to be labeled as green, then you need this certification. So if the final thing is the cost on the capital investment, so this is quite straightforward. So either finance is justifiable and available or it isn't. And you can always justify that financing is good if it is about, say, 1 year to 2 years and so on. And then the focus is on prioritizing opportunities, always the low cost first, and then capital projects are also identified and justified. So it's only in the last part, whether you want to have some capital investment or not, and that can be budgeted according to your schedule. So basically, that is what I have to present, and it's quite an overview of these two standards, and the standards are very, very comprehensive, and actually it's a long story behind the standards and so on. But in the simplified version, that is what it is. Thank you.